nuclear waste, SMRs, and fusion, the future of nuclear power. What if we told you that all nuclear waste ever produced by every nuclear power plant in the world, over more than 60 years, fits inside a single large building? That surprises most people. Nuclear power does have one genuinely difficult problem, and it deserves an honest answer. Today we're going to look at the waste problem and at two technologies that could change nuclear's future completely. The waste problem, in honest perspective. Nuclear power does produce radioactive waste and high-level waste. The used fuel rods remains dangerous for thousands of years. That's a real challenge, but here's a perspective that surprises most people. All the high-level nuclear waste ever produced by every nuclear power plant in the entire world, if you stacked it all up, would fit into a single large supermarket. The volume is tiny, it's solid, it can be contained, and it doesn't go anywhere on its own. Now compare that to carbon dioxide, the invisible greenhouse gas released by burning fossil fuels. We have released over 1.5 trillion tons of CO2 into the atmosphere since industrialization began. It's invisible, it weighs effectively nothing, and it will remain in the atmosphere for centuries. No supermarket could contain it, and we can't put it back. This does not make nuclear waste harmless. It means we can actually keep track of it, put it somewhere, and seal it away. The CO2 is already out there. Onkalo, the world's first permanent solution. The world's first permanent underground storage site for nuclear waste is being built in Finland, a place called Onkalo, which means cave in Finnish. Engineers are drilling tunnels 430 meters down into solid granite, some of the oldest and most stable rock on Earth. To give you a sense of scale, the Eiffel Tower is only 330 meters tall. Onkalo goes deeper than that, straight down. The waste will be sealed in copper canisters surrounded by a special clay called bentonite that swells and seals tight when it gets wet, forming a natural barrier around each canister. Finland plans to begin depositing waste there around 2025, with the tunnel sealed permanently over the following decades. If this design works as intended, those canisters should remain sealed and undisturbed for around 100,000 years, longer than modern humans have existed on Earth. Small modular reactors. Can nuclear get cheaper? One of the biggest criticisms of traditional nuclear power is cost. Large nuclear plants are enormously expensive and can take 10 to 20 years to build, in part because every plant is essentially custom designed and assembled by hand on site. A new approach is trying to change this. Small modular reactors, or SMRs, are standardized factory-built reactors with a capacity of 50 to 300 megawatts. A megawatt is roughly enough to power 1,000 homes, compared to traditional large plants that produce around 1,000 megawatts or more. They are designed to be assembled in a factory, shipped to a site, and put together like building blocks, faster, cheaper, and more consistent like the custom on-site construction. You can also add more modules as your electricity needs grow. Canada is one of the first world leaders in this technology. Ontario Power Generation is building BWRX-300 reactor at Darlington, Ontario, which would be the first SMR construction to begin in the Western world. But it's important to be honest. SMRs haven't been built yet and operated at commercial scale. We do not know yet what their final cost would be. The answer will come in when the first ones are actually running. Fusion, the dream that is getting closer. Everything we have talked about in this series. Fission, that means splitting heavy atoms apart. Fusion is the opposite, pushing light atoms together. It's what powers the sun. In December 2022, scientists at a U.S. government laboratory in California achieved something researchers had been trying to do for 70 years: fusion ignition. For the first time in history, a fusion reactor produced more energy than laser energy used to trigger it. A historic milestone, like the Wright brothers' first flight. Fusion fuel comes from special forms of hydrogen called isotopes, slightly different versions of the same element, and one of them, called deuterium, can be found in ordinary seawater in huge quantities. A successful fusion power plant would produce no long-lived radioactive waste, have no risk of meltdown, and draw on a fuel source available to every country on Earth. A working commercial fusion plant remains decades away, but progress is generally accelerating. Private companies are aiming to build pilot fusion plants in the 2030s. Whether they succeed is one of the most interesting science questions of our lifetime. A different tool for a different problem. Nuclear power isn't the answer to every energy challenge. It's expensive, slow to build, and the waste, while in small volume, is a real responsibility. Those things matter. But on the two questions the world is most urgently asking right now: how do we produce reliable electricity at all hours? And how do we do it without releasing carbon dioxide? Nuclear's record is remarkable. Solar and wind only produce power when the sun shines and the wind blows. Nuclear runs 24 hours a day, 7 days a week, in any weather. That makes it a very different kind of tool, not better or worse than wind and solar. A different tool for a different part of the energy problem. And a tool that deserves a fair look based on numbers, not on fear. If you were in charge of your country's energy future, would you build more nuclear plants, or would the waste problem and building cost make you choose something else? Tell us why in the comments.